Hey there, hope you're well. So today we are going to look at an AWS auto-scaling group with a load balancer in front of it. And before we dive in, I want to give you some reference. This is from the AWS site. It's known as three-tier architecture or three-tier web architecture, as it says up there. And this is one of the standard things that they're always trying to promote. It's kind of cloud native cloud architecture for virtual machines, which is what they call EC2. And it's called three-tier because there's three different tiers. So there's the web or the presentation tier. There's the app, or I think sometimes they also call it the business tier, the logic tier. And then finally you have a database tier. So the idea is that your web tier is going to be like Nginx or Apache or something like that, and this sits in a public subnet, kind of exposed to the world, let's say, but more protected is going to be in private subnets, your app tier and your database tier. And this will execute the business logic. It could be running on, I don't know, it could even be something like Python, but more commonly probably something like, let's say, Java, for example. And this will do almost everything, but it will rely on this database tier for obviously storing rows of information, storing and retrieving. Now, today I'm just going to show you the web tier. That's all I need to show you to demonstrate the auto scaling group and the load balancer. We will come back later and do also an app tier and a database tier. I'm going to do a demo on that, but we're not going to code them, so I'm just going to sort of show it off to you at some point. But today we're just looking at the web tier, public subnet. I'm going to do it just like this with two availability zones and a load balancer in front. Okay, and you see here there's an internet gateway as well. This is on the, let's call it, within the VPC or on the periphery of the VPC. It doesn't live inside a zone, and it just provides access to the internet. If you've heard of something like a NAT gateway, we don't need to use that. So these machines here will need access to the internet, but they can just do that directly from the internet gateway because they're already in a public subnet. These machines here, being in a private subnet, when we do that one day, they would need a NAT gateway in order to get to the outside world, but we're not concerned with that. So with that said, let's take a look inside the AWS account. Now what I've done is I've screenshotted some examples inside my account, and the reason is because there's a lot of, let's call it, personal information, account numbers. My username is not a big deal, but my account number I don't particularly want to expose, so it's better that I just took some screenshots. So we start here with the VPC. And what I've got here is within the VPC I've created two subnets. This is all in US East, so one's in availability zone 1A, another is in 1B. And we're looking at one route table here that I've also created. Now you see there's another one above it, this grayed out one. AWS, it creates a default route table, and you can't even delete it. And I don't want anything to do with that. I want to create my own, and I've associated that with these two subnets. And there's a route here to the internet gateway. That's the key thing. Okay, there is another route that you don't see, but it says here including local, so basically one subnet can communicate with another if necessary. But the main one I wanted to show you is that there's a route through to the internet. You do have to add an explicit route to the internet gateway, otherwise it won't work. So let's look at the next slide. Oh, and by the way, it's /16 the VPC, and the subnets are /24s. So I could have up to roughly 250 subnets. I've only got two, and within these two I could have up to 250 or so virtual machines. But as you'll see, we're only going to have one in each. But with auto scaling we can go up to 2, 3, 4, 5, as many as we want within that limit. So next slide. So the auto scaling group. Now the way this works in AWS is that you start with a launch template, and the launch template is what we're looking at down here in the details tab. Down here, sorry. So the main thing is the machine and the AMI. So this AMI is Amazon Linux 2, and this here is the machine type, in this case T2 Micro, which is perfectly fine for what we're doing. What you don't see here on the launch template is there's also some user data, so it will install HTTPD, which is basically Apache. And this is the most common example that you see, even by AWS themselves, of what to launch your virtual machines with. Now, of course, if you get more advanced and you want to have like quick warm-up time in your ASG when you scale out and you add new instances, then what you might do is, instead of running a script to install Apache and run it, is you probably would use something like Packer to bake an image, and that way you get faster launch times. But it's not really necessary for this simple example. We've got here, as part of the ASG as well, we've got here desired 2, minimum 2, maximum 2. So I just want to keep this on 2. I don't want it to suddenly scale in or scale out for the time being, and we're just leaving it as this. And what this will do with 2, it will put 1 in each availability zone. So let's look at the next slide. Now, we also need a load balancer to front this. I mean, without the load balancer, you could actually just go, if you enable your security groups, you could go just directly to each VM, and half of the user base could go to one VM and half of the user base could go to the other VM. But obviously that's not really very good. It's much better to put a load balancer in front of the virtual machines. So that's what we've got set up here, and it's an internet facing load balancer. So there's 2 types. You can have an internal one, or you can have an internet facing one. So in our case, we want it to be internet facing. It needs to have a public IP on the endpoint. It's also of type application. So what this means is it's a layer 7 load balancer. Now there is another one called a network load balancer, which is a layer 4 load balancer, and that understands TCP and UDP. But in most cases, you will just use an application one. In theory, there's a bit of an extra overhead and it's slightly less performant compared to a network load balancer, but you need this if you're running a website. If you're running HTTP, then it needs to be layer 7 or application, or basically the presentation layer. Otherwise, certificates, cookies, all that stuff, it just won't work. So that's what I've chosen here. And just a summary, you can see that it's operating connected to those 2 VPCs. So there we go. Something I didn't mention before, so we'll go back to see it on the slide, but I said that these are public subnets. In AWS, when you create a subnet, there is no switch to say public or private. What makes a subnet actually private or public is a public one has a route that goes to an internet gateway directly to the internet, and that makes it public. A private one doesn't have a route to an internet gateway. Now, it can still reach the internet because it might have a route to a NAT gateway. So that's a bit like you being at home, your laptop at home in your own internal network. You would call that, let's call it a private subnet or a private network, and your router, broadband router, is kind of like a NAT gateway. So you have a route to that, and therefore you're private. That's kind of similar. So I've scrubbed out some of the private information here, but when I created this, it returns this DNS name. We're going to test this out later. So that's the basic load balancer information. And connected to the load balancer is something you also have to create, which is called a target group. This target group connects to the ASG. And actually what it does is it reports back the number of healthy and the number of unhealthy instances. And these health checks here, which we're going to look at in a second, they're actually separate. The auto scaling group also has its own health checks, which it uses to determine if all the instances are healthy, and if any are unhealthy, you kind of destroy or partially destroy some of the instances. It uses its own health checks to recreate an instance or a virtual machine. Now, a load balancer has its own health checks. And the reason a load balancer has its own health checks is to say, right, these are the targets, and I'm only going to route traffic if the target is healthy. and if it's unhealthy, I'm not going to route traffic. Okay, and it looks at it in a slightly different way. So an ASG, an auto-scaling group, how does it know if an instance is healthy or not? Well, there's a few checks that it runs, but they're basically like machine checks, whereas a load balancer through the target group with its own health checks, I'll show you now, it has different way of determining, is this healthy and can I route traffic to it? So in this case, it tests, can I via HTTP reach the path / or the route on port 80 and get a success code of 200 with these parameters, a timeout of 5 seconds every 30 seconds, and a healthy threshold would be 3 consecutive health checks, and it will go unhealthy when it's 3 consecutive failures. So a load balancer health check is very specific to serving traffic. An auto-scaling health check is more about, well, is this machine, is it switched on kind of thing. So that's roughly the difference. And we have here that there are 2 healthy, which is great. Now you can just, instead of this load balancer, let's call it traffic related health check, you can just have regular machine health check. AWS actually gives you a choice for your load balancer. And in my case, I turned on load balancer health check. It's called ELB health check. You can just have EC2 health check, which is just the same as ASG, but I prefer not to. Remember, this load balancer is connected to an ASG, right? Those targets, but you can just have it connecting to just one VM, and with no ASG, just a single VM. It's not really balancing anything, because it's just going from load balancer directly to one VM. But in most cases you have a load balancer connected to an ASG. Now I just want to show you the security groups. I decided to show you my Terraform code instead because it's a bit easier to see all of the rules on one page. So I've actually got 2 security groups. I've got this one here, the ASG security group, which we're going to start with. I've also got a load balancer security group I'm going to show you in a second. But in the ASG security group, you have, let's start with egress. This just means allow all access to anywhere, 0000/0. So anywhere, any port, any protocol, allow all egress. But on the ingress, what we said here is only allow TCP on port 80, and the source is only from the load balancer. Okay? So that means that even though this is in a public subnet, do not allow anyone to go direct to the VM, only through the load balancer. And this is the real power of security groups in AWS. I'm not sure you could really do this ordinarily, very easily in the pre-cloud world. Maybe you could on some special load balancer appliance. You could do some funky stuff. But I don't think this really was a thing until the cloud came along. So this is pretty cool. It says these VMs can only accept traffic from the load balancer that's in front of the VMs. They cannot get, nothing else can get through to it. Now that's the ASG security group. Let's look at the load balancer itself. And again, we'll start with egress. It can go out to the internet, no problem there. Now, of course, this is just for tests. Potentially you could lock these outbound groups down, and lock it down. It can only reach certain repos or something like that. But this is just for the demo. We're not too concerned about that. On the ingress, you say, right, we want to accept TCP port 80 traffic. So this is from our users, and they could be anywhere in the world. Of course, you could restrict that maybe by, I don't know, by country or something like that. Although you probably use something else for that, maybe possibly a CDN or something else. But in our case, we're just saying, look, allow all internet access TCP port 80. So that's that. Let's go back, and I want to show you exactly how this works. And just before I just go back to this diagram, I want to raise that point again. So knowing everything that we know, you might well think, well, this load balancer has a public IP. It has a public endpoint. It's exposed to the internet. Great. That's what we want. We want people on the internet, our users, to be able to reach this load balancer. It has to be publicly exposed. And you might be saying, well, why is this in a public subnet? Why are the VMs sitting, the instances, EC2 instances, why are they sitting in a public subnet? Is that not a bad thing? Well, yeah, this also occurred to me, right? So, first of all, we do have security groups, and they prohibit any inbound access except from the ELB. Okay? So, that's great. We are protected, luckily. And the only thing, even though this is called public, the only thing that really makes it public is that it has a route to the internet through the internet gateway. That's what makes it public. So you might be thinking, well, why not just stick it in a private subnet and have the internet access be through a NAT gateway? And that's a valid point, and I have seen other diagrams showing exactly that architecture. But for whatever reason, the AWS 3-tier web architecture that they like to advertise, the web tier always sits in a public subnet, in a subnet that has a route to the internet through an internet gateway. So it can sound kind of quote unquote dangerous, but it isn't really. It's not dangerous at all. These EC2 instances do not have a public IP attached to them. That's specifically not turned on. So don't read too much into the public subnet. It's not the same as a DMZ in the old school world. These are not dangerously exposed to the internet. They're not at all. This is perfectly fine. It's really, the terminology is just a little bit confusing. So finally, let's test this out. Let's see if our load balancer will deliver traffic to each of these instances. So what I did in the user data was I have the instances display on the web page the instance ID, and I think maybe the IP address, I'm not sure, but they will definitely display the instance ID. So if we go back here quickly, I just want to show you on that previous slide a couple of the instance IDs. There we go. We've got one starting 062 and another 012. So let's go to the web page. And there you go, there's one of them 012, and if I keep hitting refresh, 062. I just keep refreshing and it's going 062, 012. Of course, what you would do is if you're running a real application and you were running, by the way, this is only HTTP, I'm not setting up certificates or anything, but if you were doing it properly, you would set up sticky sessions with cookies, and that way you would ensure that the user is always on the same instance, and doesn't keep flipping the instance. It keeps the session relevant information on that one instance, and they stay on that instance. But in this case for the demo, we just want to show that this is basically a kind of round robin situation where you're hitting each instance roughly 50-50. So, well, that there was the AWS 3-tier, just the web tier, part of the 3-tier web architecture. So I hope you found this demo interesting, and please let me know what you think. Leave a comment below. Any questions or comments, please give this video a like if you liked it. Subscribe to the channel. I will see you again soon. Take care. Bye bye. Hey, I just want to say a little extra about these EC2 instances that are web servers living in this public subnet. In theory, there is a risk that if these were given public IP addresses, then they could potentially be individually accessed by someone on the internet by virtue of being in a public subnet and therefore routing to an internet gateway. However, in the cloud native world of AWS, your primary line of defense is always your security groups. So as long as you don't configure the security group on these instances to allow traffic from anywhere except this load balancer, then you're perfectly well protected. So the way of using subnet profiles, whatever protection is on at the subnet level, as a method of doing security it's a little bit outdated. It's used in the days of non-cloud security, and it's still here as a measure, as are other measures, for example network security groups. But you should be leading the way with regular security groups, as we've seen, and locking them down and having two security groups, one on the ASG and only allow traffic from the ELB, one on the ELB, only allow traffic from the internet on port 80. And as long as you do that, it's perfectly fine to have this arrangement. And that is why AWS, you can see it for yourself, they advise this arrangement. So I just wanted to make that clear. It's not like there isn't a use case to put these in a private subnet, but the security argument for it is not just overblown, it's a bad argument in many respects. And you can see that even AWS themselves say, put your web servers in a public subnet. There's no problem doing that whatsoever because you have security groups. So I just thought I'd mention that. Thanks for watching. Bye bye.